So we've all seen that trick where a friend goes up to someone and taps his beer bottle on the top of another, and the beer inside quickly turns to foam and erupts from the top. So what exactly causes this reaction to happen? This common party foul can be explained with some simple fluid mechanics.
When the bottle of beer is initially struck with another bottle, a compressional wave is generated and propagates down through the bottle. Here on the screen is a mathematical description of a compression wave, where K is the bulk modulus, G is the shear modulus, and ρ is the density of the media it is passing through. As a compression wave passes through a media, it increases its pressure, density, and temperature. However, in this instance, temperature change of the beer and glass can be neglected. Once the compression wave reaches the base of the bottle, it then returns to the top of the bottle, but now as an expansion wave. An expansion wave acts oppositely of a compression wave by decreasing pressure and density of the media. Once the expansion wave reaches the top of the bottle, it will then return back to the bottom of the bottle as a compression wave. This cycle repeats until all energy has been removed from the system due to energy loss in the form of heat and acoustics. Therefore, each subsequent wave has less energy than the previous wave.
The rapid fluctuation of compression and expansion waves causes cavitation to occur in the beer. Cavitation is the formation of bubbles or cavities in a liquid due to the static pressure dipping below the vapor pressure. In this case, it leads to the formation of foam in the beer. When compression waves travel down, they condense the beer until it forces the tiny bubbles in the beer to collapse due to the increased pressure. When these bubbles collapse, they separate into many more smaller daughter bubbles. Beer is a carbonated drink, meaning there is carbon dioxide present in the liquid. When these large clouds of daughter bubbles form, the CO2 gas present in the beer can find its way into the bubbles very quickly and much easier than before because of the increased surface area of the bubbles. As the daughter bubbles absorb the CO2, they expand rapidly, filling up with gas that causes them to become buoyant and float to the top. This combination of reactions is what leads to the beer erupting from the top of the bottle. The original bubbles in the beer take up much less space than the daughter bubbles full of carbon dioxide. Since the bottle cannot expand to make up for the increased pressure, the beer bubbles are forced from the mouth of the bottle, mostly made up of CO2.
So would resting the beer on a table help mitigate or even stop the process of beer imploding in the bottle? Since the process is started by a compression wave acting like a sound wave, then wouldn't some of the wave be absorbed because the object that the beer is resting on would act like a spring and absorb some of the energy? Well, it turns out that, as we see in our video, it may have helped, but it did not stop, and it hardly did anything to help the beer from not imploding.
As we observed, this party trick is caused by a rapid flux of compression and expansion waves traveling through the bottle. The process cannot be stopped until the energy put into the bottle from the tap is dissipated. The energy is dissipated by the process of cavitation. Basically, what causes the beer to erupt from the top in the form of foam is cavitation. Foam basically is a mix of beer and CO2. Based upon the results documented in the video, it can be concluded that the beer still implodes while on surface. Although the surface does not completely absorb the propagating shock waves, the reaction of the foaming of the beer is slowed down.